This star you're seeing now, I bet 99% of you recognize it. That's right. It's the morning star, also called Venus. It's the closest planet to Earth, like Earth's twin brother. Their size, mass, and composition are almost identical. Since it usually appears in the morning, and apart from the sun and moon, it's the brightest thing in the sky, seeing it means a beautiful day is about to begin. That's why people affectionately call it the morning star. Actually, the morning star doesn't just appear at dawn. You can see it in the evening too. But I have to tell you guys, the morning star isn't as lovely as Earth. Its cloud tops float with toxic sulfuric acid mist, surface temperatures hot enough to melt lead into shining streams, atmospheric pressure that could instantly crush most submarines on Earth. Latest satellite photos show thousands of volcanoes actively erupting on Venus's surface. The largest, Maat Mons, would create 3-meter-high lava flows if placed in North America. What makes Earth's twin brother so drastically different from our home planet? This episode, we're diving deep into Venus together. Get your snacks and drinks ready. We're about to flip some perspectives. Let's go. The earliest human records of Venus trace back to the Sumerians in 1600 BC. They not only noticed Venus, but accurately calculated its 8-year, 5-cycle orbital pattern. This was 3,000 years before the telescope was invented. Ancient records also appeared in similar periods. Remarkably, ancient observers used only naked eyes to measure Venus's phase changes. Those observations written on bamboo strips are so accurate that when scientists simulate them with computers today, the error is less than 3 days. When the Mawangdui Han tomb was excavated, they found the 5 planets divination text. On 2,000-year-old silk, it recorded Venus's synodic period as 584.4 days. That's only 0.48 days off from modern calculations. In modern times, humans have launched at least 46 probes to Venus. About half actually completed their mission successfully. Here's some key information I've compiled about these probes. Initially, scientists thought Venus, being so close to Earth, should be perfect for life. But on December 14, 1962, Mariner 2 completed a 109-day flight and successfully flew past Venus. Its infrared radiometer measured Venus's surface, reaching up to 465 degrees Celsius. This discovery completely shattered scientists' previous assumptions that Venus might be a mild, moist planet suitable for life. Venus has an extremely dense atmosphere, mainly carbon dioxide at 96.5%. This is one of the main reasons for Venus's extreme surface temperatures. The atmosphere contains thick cloud layers, but these aren't made of water vapor. Mariner 2 wasn't sure what they were made of at the time. Later probes discovered the clouds are mainly sulfuric acid. Mariner 2's microwave radiometer showed Venus's atmospheric pressure was about 20 times Earth's. This wrong 20 times pressure data led the Soviets to miscalculate Venus's conditions. They launched 6 probes to Venus in succession, all ending in failure. Mariner 2 also found Venus has virtually no magnetic field, less than 1/10,000th of Earth's strength. This suggests Venus's internal structure is completely different from Earth's. It probably doesn't have a liquid metallic core like Earth, or its rotation is too slow to generate an effective dynamo effect. Venus takes 243 Earth days to rotate once, the slowest rotation in the solar system. It's also the only planet that rotates backwards, from east to west. So if you stood on Venus, you'd see the sun rise in the west and set in the east. Venus orbits the sun in about 225 Earth days. Remember how long one Venus day takes? Right? 243 Earth days. That means on Venus, a day is longer than a year. This makes Venus the only planet in the solar system where the rotation period exceeds the orbital period. Mariner 2 also confirmed that solar wind exists continuously, laying groundwork for future solar sail research. After completing most of its mission, Mariner 2 suddenly lost contact with Earth. This was probably a common problem for probes of that era. They'd just lose contact unexpectedly. Like the Soviet Venera one, which planned to fly by Venus but lost contact before reaching its destination. Earlier, we mentioned the Soviets launched 6 consecutive Venus missions that mostly failed. Finally, on August 17, 1970, the Soviets got Venera 7 to Venus after just 4 months of flight. Venera 7 successfully landed on Venus's surface, the first human-made object to land on another planet's surface. Thanks to previous probe data, Venera 7 could withstand 180 atmospheres of pressure and 500 degrees Celsius temperatures. Even so, Venera 7 only worked for 23 minutes. It measured Venus's actual surface temperature between 455 degrees Celsius and 495 degrees Celsius. Atmospheric pressure was 9,000 kilopascals. That's 90 atmospheres, equivalent to pressure 900 meters deep in Earth's oceans. This discovery corrected NASA's Mariner 2 error of 20 atmospheres and explained why previous probes couldn't survive long. Since they'd found the problem, the Soviets launched Venera 9 and Venera 10 in June 1975. They landed in 2 different regions of Venus. Venera 9 survived only 53 minutes before losing contact. Its 360-degree panoramic camera had only 1 working unit, so the photos showed just 180 degrees. But the images were quite clear, looked a bit like Earth's desert landscapes. Venera 9 measured surface temperature at 485, plus or minus 15 degrees Celsius, atmospheric pressure at 90 atmospheres. Light intensity was like an overcast day on Earth, with wind speeds of 0.4 to 0.7 meters per second. The photo you're seeing now was taken by Venera 10. Venera 10 landed in a gentler area. From the photo, it doesn't look too different from Earth. Venera 10 measured surface temperature at 465 degrees Celsius, lower than Venera 9. This showed temperature variations exist across Venus. Soil and rock measurements found rock density of about 2.8 grams per cubic centimeter. Very similar to Earth's basalt, so scientists once thought Venus and Earth were truly twin planets. On October 30, 1981, the Soviets launched Venera 13 to Venus. This probe endured 90 atmospheres and nearly 500 degrees Celsius temperatures, surviving a record-breaking 127 minutes. For the 1980s, Soviet technology was truly impressive. Venera 13 had a drilling device and X-ray fluorescence spectrometer. It successfully drilled 3 to 5 centimeters and collected samples for on-site analysis. Results showed Venus's surface rocks were similar to Earth's basalt, with high concentrations of potassium, uranium, and thorium. This discovery confirmed the geological similarity between Venus and Earth, again supporting the theory that both planets might have similar origins. Interestingly, Soviet scientists installed a microphone on Venera 13, but the microphone broke, so they installed another one on Venera 14 a month later. That one successfully recorded Venus's sounds. Venera 13 also sent back the first color photos. You can listen carefully to these sounds from Venus. NASA launched the Magellan probe to Venus on May 4, 1989. This was humanity's first comprehensive, detailed mapping of Venus, completely changing our understanding of the planet. Magellan carried a synthetic aperture radar system, advanced technology that could penetrate Venus's thick cloud layers. Unlike ordinary optical cameras, radar can see through clouds to map detailed surface topography. Magellan's radar resolution reached 75 meters, meaning it could identify objects the size of a medium building on Venus's surface. The probe also had altimeters and radiometers to measure surface height variations and thermal radiation characteristics. These instruments worked together, giving scientists unprecedented detailed views of Venus's surface. Magellan mapped 98% of Venus's surface at much higher resolution than any previous probe. These detailed maps revealed many amazing discoveries. Magellan found over 1,600 volcanoes on Venus's surface, far exceeding previous estimates. The largest, Maat Mons, rises 8 kilometers high, a giant shield volcano. Probe data suggests many of Venus's volcanoes might still be active. This contradicted previous beliefs that Venus's geological activity had stopped. Unlike the Moon and Mercury, Venus has relatively few impact craters, and most are well preserved. This indicates Venus's surface is relatively young, possibly experiencing global volcanic activity in the past 500 to 800 million years that covered early impact traces. Magellan discovered Venus has massive rift valley networks. The largest, Artemis Chasma, stretches 2,100 kilometers long and 300 kilometers wide, one of the largest rift valleys in the solar system. Magellan's data shows about 80% of Venus's surface is covered by lava flows. Some of these flows extend hundreds of kilometers. These discoveries confirmed Venus experienced massive volcanic eruptions, possibly a key factor in creating its extreme environment. 5 years later, Magellan completed its mission. Scientists guided it to crash on Venus's surface. It was the first probe to perfectly complete its Venus exploration mission. In September 2020, scientists detected phosphine in Venus's cloud layers. This discovery excited scientists because, on Earth, phosphine comes mainly from two sources: human agriculture and industry, or microbial production. So scientists see it as a potential sign of biological activity. This research was discovered by a British professor's team. First, they used telescopes to observe Venus and unexpectedly found phosphine's spectral signature. To confirm this discovery, the team conducted higher resolution observations and again detected phosphine. Both independent observations showed about 20 parts per billion of phosphine at 53 to 61 kilometers altitude in Venus's clouds. This region happens to be where Venus's atmospheric temperature and pressure most closely match Earth's surface conditions. Temperature around 30 to 60 degrees Celsius, pressure about 50 to 100% of Earth's surface pressure. Based on these findings, scientists began suspecting that somewhere on Venus, certain anaerobic microbes might exist. They could produce phosphine in oxygen-free environments. According to existing chemical models, non-biological processes produce far less phosphine than observed concentrations. Even more surprising, Venus's highly oxidizing cloud environment should rapidly decompose phosphine. This means something must continuously produce phosphine to maintain observed concentrations. But until now, scientists have no definitive evidence to prove this. This discovery directly pushed forward a new round of Venus exploration plans. The U.S. announced 2 new Venus missions, Da Vinci Plus and Veritas, planned for launch between 2028 and 2030. Da Vinci Plus will directly probe Venus's atmospheric composition, hopefully confirming phosphine's presence and searching for other biosignatures. The European Space Agency, India, Russia, and private space companies have all announced their own Venus exploration plans. If this discovery is confirmed, the habitable zone range will be greatly expanded. This is Cosmic Canvas. I'm Starweaver. If you love space exploration and unsolved mysteries too, please hit that like and subscribe button. See you next time. Love you all. Bye.